So today's 2.B average rate of change. So average rate of change is essentially the average of the rate of change over a period of time, okay? Now we are going to learn next week about instantaneous rate of change, which is where we can find the exact rate of change at an exact point. But for now, we only know how to find an average, okay? So if we have something like this, if we want to find the average rate of change, we essentially calculate the slope between these 2 points. So you see how in calculating the slope between these 2 points, we don't get the exact rate of change of the curve, but we can get an approximation. And then to calculate slope, you can either use rise over run, or you can use x squared, delta y over delta x. Y2 minus y1 over x2 minus x1. So what's important to know is that the average rate of change for a nonlinear function will always create a secant line, okay? A secant. You guys are understanding this, right? Because this is important for your upcoming quizzes and stuff.
I don't know what secant is.
A secant is a type of line that touches 2 points on a curve or a circle.
Oh,
So it's important that you know that vocabulary for a test or quiz.
Like those triangles they form the circles, is that would be like 2 secants?
Exactly. We learn in geometry about secant line versus tangent line. Tangents touch once, secants touch twice.
I never heard that, but okay.
I can show you where it is in your geometry stuff.
Oh wait.
So to calculate average rate of change of an interval, you essentially have to plug in the endpoints to get their corresponding y-coordinates, and then you need to, whatever 2 coordinates you get, you need to calculate the slope, okay? So for the first one, you see how they give us an interval of -1 to 1?
Yeah.
While I do the notes, guys, can you get off your phones?
Yeah, Robert, get off your phone. Not doing what, Robert?
Okay. So we have f of 1, or f of -1, is equal to, we plug -1 into the function, we get 1 over -1 is equal to what?
-1.
Good. So that's going to give me -1 comma -1. Alright, so for the next one, we have f of regular 1. So we're going to plug regular 1 in. We get 1 over 1, which is what?
1.
Very good. So we have 2 coordinates. We have -1, -1, and 1, 1. So now if we want to calculate the slope, you just calculate the slope between 2 points. M, or the slope, is equal to, or average rate of change. We can do either one first, it doesn't matter. I'm going to use this one as the second one, so I'll just do -1 minus 1. So this minus this over this minus this. That's how you calculate slope. And that should give you -2 over -2, which is what? 1. Anything over itself. So, it's okay. I'm glad you're participating. So, your average rate of change is 1. So does anyone have any questions about why the average rate of change is 1? Alright. So for the next one, find the average rate of change for this function over this interval. So this is an important one because you're going to notice sometimes when you calculate average rate of change, you're not going to get a nice number. You're sometimes going to be left with something that has an irrational number like e or pi. Does anyone remember what we call e?
Like the number?
Yeah, what is it called? Like approximate.
Constant?
Well, yeah.
It's like
something about a natural log.
Yeah, we use it in natural log. It's called Euler's number. It's like 2.7. So the main thing you need to know about this is another thing like pi, where it's an irrational number that we use a letter symbol to represent. So it is just a number, just like anything else.
Right.
But we don't actually use it like to calculate. We're not going to use it as a decimal. We're going to leave it as a whole number. Okay. So we're gonna go ahead.
So you just leave it as e?
Yeah, you leave it as e.
Okay.
So we're going to plug in -1. We get e to the -1. Does anyone remember how we can make an exponent positive?
1 over e.
Thank you. 1 over whatever that exponent is. If it were e squared, to the -2, you do 1 over e squared. So we just can make that exponent positive by bringing it to the denominator. Okay. So that means we have a coordinate of -1 comma 1 over e. Then we're going to plug in 0. That's e to the 0 is equal to, what is anything to the 0 power?
1.
1, good. So that gives me 0, comma 1. So those are my two coordinates. Now I can calculate the average rate of change. So average rate of change is equal to the change in y over the change in x. I'm going to do 1 over e minus 1 over negative 1 minus 0. So that's basically just going to give me a negative 1 in the denominator, right? Which means I'm dividing each of these terms in the numerator by a negative 1. So that's just going to become negative 1 over e plus 1 as my final answer. So like I said, sometimes average rate of change will not be an exact number. So if you were to put this in the calculator, there is a button for e on that calculator. You could get a decimal approximation, but you couldn't get an exact number with a calculator, just like if you were to do pi or a square root, it's always rounded. So does anyone have any questions about that? All right. Yes?
If we put the decimal version, would that be wrong on the test?
I would ask for the exact value. I don't really ask for decimals very often for things like that. That's more something you do in like physics or another science class. But occasionally I might ask for it, but unless I do, always give me the exact value in math.
Miss, you could do it both ways and it would still work, right? Like
Correct.
1 minus I over e.
Yes. Yeah, good question. So
What 1 over e, not I?
That's what I meant.
yeah. I know what you meant. So she's just saying, like, if you were to use this as x2, y2, and this one is x1, y1, if you flip them around, would it matter? You can pick either point to be x1, y1, and x2, y2, as long as you keep the order consistent on the top and bottom when you do slope. All right. So for the next one, find the slope of the secant line between x equals 1 and x equals 4 for the function. So we learned earlier that secant line represents what?
Point from like a line, straight line from one point to the other of a circle.
Yeah, it basically just represents the average slope or average rate of change on any curve, right? The average slope. So we can calculate it the same way we calculate average rate of change. So we're going to plug in 1, and we're also going to plug in 4. So each of these is going to give us a corresponding y. This is going to give me 4, so that gives me a coordinate 1, comma 4. And this one is going to give me 19. Good. So this gives me 4, comma 19. So like I said, you can pick one of them to be x1 and y1, other one to be x2 and y2. If you had them switched, you get the same answer at the end. So your average rate of change is equal to y2 minus y1 over x2 minus x1, which gives you, it is 5, very good. So what that essentially means is if you were to graph this quadratic function, and you were to plot these 2 points, if you were to draw a line between them, it's going to have a slope of 5. So does anybody have any questions before we move on to the next one? Okay. So the next one kind of asks us to use a conceptual understanding of what we just learned about. So we're looking at a graph, okay? And clearly this graph is not linear, so we're going to have to use average rate of change, because linear functions are the only type of functions that we can calculate exact slope, right? Right now. Next week, though. So find the average rate of change of f on the interval from 20 to 60. So if I look at the point at 20, and I look at the point at 60, I want to find their corresponding y values, right? So what would be the y value at 20?
200.
300, right? Because it's between the 200 and the 400. And then what about 60?
700.
700. And now that we have that, we can just go ahead and calculate slope. So remember, change in y over change in x. That's going to give me 700 minus 300 over 60 minus 20, which gives me 400 over 40, which is 10. So my average rate of change is 10. So identify the interval on which the average rate of change is 0. So instead of just picking random points and calculating slope until we get 0, there might be an easier way to do it. So if a line has an average rate of change or a slope of 0, what does that line look like?
Flat.
It's flat. Good. So what we want to do is we want to essentially find any lines on here that we can create between 2 points that are flat. So the two that I can come up with and think of are this one right here, between 10 and 50. And then there would also be one between 0 and, what is that, like 58-ish, right? So you could find multiple of these, but usually you want to pick the one that's the most exact, right? So I'm going to go with the one in the red because it gives me two exact numbers, which are 10 and 50. So if we were to calculate the average rate of change between 10 and 50, the math answer would also be 0, okay? But you didn't have to do the math because the visual was enough. So the next one says, which interval gives the larger rate of change, 40 to 60 or 40 to 70? So there's two ways to go about this. You could just individually calculate the rate of change between each of those mathematically like we did in letter A. But we could also just look at their graph and see which one has what? A steeper slope, right? So from 40 to 60, that line would look something like this. And then we'll do 40 to 70. So from 40 to 70, that line would look something like this. So it's a little bit hard to read because they're so similar. But from 40 to 60 is actually a little bit steeper, okay? So we're going to go with 40 to 60 as our answer. Now, if you weren't sure and you were on a test and it felt like they were really close, what would be a smart thing to do here? Calculate them both and just compare.
Nice roll.
Yeah. And then the last one says compute the rate of change from 40 to 10, right? So they basically set it up for us. But we can actually just do that by doing rise over run, right? So if I find a point at 10 and a point at 40, I can connect those with a secant line. So whenever you connect 2 points like that, that's a secant line. And I'm just going to actually count the slope using rise over run. So it looks like we go down how many units?
200.
Good, we go down 200, so negative 200. And then we go right how many units? Goes by tens on the bottom. 30. So the simplest this can reduce is negative 20 over 3, which would be approximately negative 6.67. And then lastly, ask what's that value represent geometrically? It represents the slope of the secant line between 2 points. So the main takeaway, conceptual takeaway, other than just the calculations, is to understand that anytime you calculate an average rate of change, you're essentially finding the slope of the secant line between those 2 points. Okay? All right. I'll go ahead and hand out your homework then.